Hi everyone, welcome back. In this session, we are going to discuss architecting deep agents. This is a visual guide to understand how modern AI agents are evolving from simple linear workflows into dynamic intelligence system. Most of the people understand agents as a simple tool calling system, but real-world AI systems are much more complex. So today, we will explain how deep agents work, and definitely there is no coding added in this video, so the coding can be added in our coming videos. And we will discuss how they plan in a high level, how they delegate work, and how they manage memory, and how they dynamically orchestrate the task. So we can cover all those things in this video. Okay. Now let's understand, or before going to the deep agents, let's understand how the existing traditional agents work. Okay, so we can say that they are linear fragility. So which means they follow step-by-step execution. Okay, for a small task, these things they work in a really good way. So I'm talking about like more complex situations. Okay, so they will execute like step by step. If something is break in the middle, the agents often get stuck in the loop and fail it completely. Okay, so they will not come back out of that particular loop, right? So that is what we call the linear fragility. Then second is the context bloat. So every conversation and every intermediate result stays inside the context window, and over the time this become too large and the model start forgetting the few important things. Then the third is the stateless execution. If the process pauses or stops, for example waiting for human approval, the agent loses its context and cannot resume properly. Then see like traditional agents versus the deep agents. So architecturally, as we said, it's a linear chain, but deep agents are like a little complex and it's a flexible mesh network, and its navigation is like one way, and deep agents are like a non-linear jumping. So for example, we have a research agent is there and validation agent, sub agent is there. So what happens is that once the research is done, it will validate and see that research is so did we have everything that we needed for to generate the result. After the research, the validator will check. Okay, if it is not, it will again do some kind of a research and the recorrect. So those kind of a non-linear jumping will happen. Then memory model, as we said, it is actually stateless too in the traditional agents, but here we will see like at every point, every checkpoint, like it will save, or it will, there is an option to offload to the memory, offload the memory to the file system. Then prompt logic, it is a we can say it's a one single big prompt, but when it is come to the deep agents, it's kind of like a modular. Then there is a situation like which architecture that we have to use, or in which situations we have to select the deep agents, or if you read it's theoretically, we may get a feel that okay, it is similar to the supervisor agent, right? Okay, so in which situation we have to use the deep agents, or in which situation we have to use the supervisor agent, so or any other like a normal architecture. So traditional way, we can say that if the task is very simple, or it can be executed with one or two agents call, or if it is not that much deep, then we can definitely go with the supervisor agent and we don't need to go with the deep agents. So deep agents are like is useful when it is like a too deep and we have to execute like a too many things and human interactions. So in that case, we will go with the deep agents. And in the supervisor agent, it is kind of like a fixed structure, but in the deep agents, as we discussed, like it is kind of a dynamic. It will plan well and it will select the sub agents based on that plan, and those kind of things will happen in the deep agent model. Now the four core pillars of the deep agents. So when we talk about deep agents, this is the four most important things. So how deep agents work? Okay, for example, when a problem comes, first it will do is the planning. Okay, just like the project management or project manager will do, first it will do the planning. Like it will say that step 1 we have to do this, and step 2 we have to do this, and it will write down the planning. So we know that we have a to do middleware, right? If you are using the LangChain framework, it will make use of this to do middleware to make the planning. So based on the planning, it will create the sub agent and it will execute it. So we will have a set of sub agents will be there. Then the orchestrator will decide, okay, which one it has to call. And the third important part is the deep agent is a file system. So the virtual memory offloading. So which means like it will save all the informations into a file system. Okay, because this definitely will help us to track the each task. I mean, task the status of each task. Okay. Then next is the prompt and instructions. As we said, like it is a kind of a modular kind of a prompt structure that we are using, but it is more than a prompt. It is more than the prompt. Like it will help us to identify the tools and the tasks. Everything will be there in the prompt. So we will go like a little bit more deep into the planning and decomposition. As we said, like in the planning phase, once we have the requirement, we will split into the small tasks. For example, I have a task like a compare Q1 and Q2 report. Okay, so first what it will do is it will create a task like fetch Q1 report and fetch Q2 report, then summarize the both and compare them. Okay, so this may be the 4 steps, and based on that it will execute the sub agents. Then okay, so it's a continuation of the first pillar. Like once we have the plan, the second is the sub agent. So based on this planning, the orchestrator will decide which sub agent it has to call, and all the details will be tracked periodically. Then we have a virtual file system and the memory. So this also helps, like consider like we have like a 1000-page of PDF. Keeping all this context information is actually inefficient, right, and expensive. So instead of that, the DPage store the information in a files. For example, save the intermediate result, save report, save extracted details. Everything will be in the memory. So whenever it's needed, it will take from the hard disk and it will execute it. Then next is the prompt. So here the prompt is not just the user messages. It's just like a middleware. It defines some rules. For example, when to call the tools, how to update memory, when to create sub agent, how validate the output. All this will be in the prompt. Okay. Now let's understand in a high level what's happening. Okay. So for example, if this is my query, like compare Q1 and Q2 in 2004 performance. So this is my user query. So we will have a user agent orchestrator will be there. So based on that, based on this query, okay, so we will call different tools, and finally we will combine and we will generate the result. Okay. So this is more by high level architecture of the deep agents. Okay, the same question, like we have like a Q1 and Q2 is there. So first we will do the pillar 1, we will do the planning will be done, and based on the planning we will have the sub agents. So these are the sub agents, like compare report, summarize the text, and the get financial informations. Then we have the file system will be there. So if it is have a the Q1 report, it will save into the memory. Then it will have a Q2 report, it will save into the memory. After that, it will take the Q1 and Q2 result and it will summarize it. Then it will compare it and it will save to the final report. So all the intermediate result will be saved into the file system. Then we have the prompt. As I said, like a prompt will direct deep agents to take necessary actions. Okay. So this is what happening with this is the high level architecture of the deep agents. Okay, so if you are working with LangChain or LangGraph or the production AI system, this architecture will really help to understand what is the deep agents. So in the next video, we can implement this practically using the LangChain and LangGraph. And if you found this useful, please do like and subscribe. So that's it. Thank you very much.